Hello and welcome to part 3 of this video walkthrough for exam style questions for the 2020 NCEA Level 2 Calculus exam. We are now on question 3 and the first part is f dash of x equals 8x cubed plus 3x squared minus 6x minus 3 is the derivative of a function f. The graph of f of x passes through the point 1, negative 4. Find an expression for f of x. So we've been given f dash of x, we've been told what that is, and we need to find f of x. So going from the gradient function, f dash of x, to f of x means integrating. We've been given a pair of coordinates that f of x goes through. That is so that we can find the constant of integration, c. So let's integrate and see what we get. I'm going to add 1 to the power and divide by the new power. I like to do this, and then we'll just simplify it in the next step. Sometimes you're lucky, like in this case, and everything sort of will divide nicely, but that doesn't always happen, of course. So let's simplify all of this. So that's going to give us 2x to the power of 4 plus x cubed minus 3x squared minus 3x plus c. Now the purpose of being given that pair of coordinates, so in this case 1, negative 4, so just remember coordinates are x and then y, or f of x, is if we substitute those into this f of x equation that we've got, that will leave c as the only thing that we don't know, which means that we can find it. So let's substitute in what we know. So we know that f of x is negative 4, and we know that x is 1. So every time I see f of x, which I know that one time, I'm going to put negative 4. Anytime I see x, I'm going to put 1 instead. And as always, brackets are your friends when you are substituting. Plus c. Okay, so that's going to be 2 plus 1, take away 3 equals c. Of course, you could do this on the calculator. So 2 plus 1 is 3, take away 3 is 0, take away 3 is negative 3, so negative 4 equals negative 3 plus c. So add 3 to both sides, that's negative 1 equals c. So what that means is f of x equals 2x to the power of 4 plus x cubed minus 3x squared minus 3x minus 1. And that's the answer. And that is an achieved that question. Okay, on to question B. A dolphin surfaces on a still sea. As the dolphin surfaces, a circular ripple expands outwards at a constant speed, so that the radius of the circle is given by r equals 0.6 meters, t seconds after the dolphin surfaces. At what rate is the area of water within the circular ripple increasing 15 seconds after the dolphin surfaces? The key here, this bit, at what rate? We've been told it's increasing, which is helpful, but the key thing is at what rate, and of course the time as well. So the dolphin will surface at time equals 0. That's a key thing. So the important thing about rate is because rate means gradient, rate of change. Gradient, to find gradients, means differentiating. Now we have been asked to find the area of the water, but this is the radius, so we actually need to first of all find an expression for the area of that circular ripple. So area of a circle is pi times the radius squared. So we've been told the radius is 0.6 times t, so let's put that into there. So area equals pi times 0.6 t, all of that squared. So area equals, so we need to work out what 0.6 squared is. That is 0.36. So that will be 0.36 pi t squared. So it's going to be this that we differentiate. So differentiate that to dA over dt. So rate of change of A with respect to t. So that will be 0.72 pi t. So this formula now, dA over dt, that's going to tell us the rate of change of the area in terms of time. Now we know the time because we were told that, 15 seconds. So we can now substitute t equals 15 into here, and this will give us the answer. So this is our gradient function, if you like. We're working out the gradient or rate of change. So put that into the calculator. And that gives us an answer of 33.9292, which we can probably just call 33.9 meters squared per second. Units aren't essential on that question, but always good to give them if you can. So we know it's meter squared per area because area is measured in meter squared, and then the time is in seconds, so meter squared per second. And that is the answer. So you'd get achieved for finding an expression for dA over dt, so that would be getting to this stage here, and then a merit for that. So really the difference between achieved and merit is substituting the 15th equation and working out. So that's question B done. Let's go on to question C. Another merit one. The graph of the quadratic function f of x together with that of its gradient function f dash of x are shown below. So you can see we have got a negative parabola, and its gradient function, as you might expect, is a negative linear graph. We've been given a couple of coordinates on that linear graph, and we've been given one pair of coordinates on f of x. So the question is actually a little bit further down the screen. No, it's not. I haven't written it. I better do that now. So the question is, find an expression for f of x. So we need to find the equation of that negative parabola. So you might be thinking, well, how do we do that? Now, the trick to this one is f dash of x. So remember, we're doing calculus. This is a calculus exam, so we're going to have to do some calculus to get our answer. The key here is the gradient function f dash of x. There is actually enough information on that graph for us to find the equation of that straight line. If we look at f of x, this negative parabola, there's not enough information to find the equation for that. So we can look at that. We only know one coordinate on it. That's not enough. We don't know the location of those intercepts or the turning point. So we can't use that graph of f of x to find the equation of f of x with that information. So that's what points us in the direction of f dash of x. So the key here, remember that general formula for a straight line is y equals mx plus c, where m is the gradient and c is a constant that shifts the graph up or down. So c also doubles up as your y-intercept, which we have been given. So c must be 3. Now we can also work out the gradient by doing rise over run. because it's a straight line, so that's how we can do that to work out the gradient. Now, because we've been given 2 points, we can work out the gradient. So this one, the coordinates are 0, 3, and this one, the coordinates are 4, 0. So we can go, okay, well, from 3 down to 4 there, from 0, 3 down to 4, 0, we've gone down by 3 and across by 4. So our rise is -3 and our run is 4. So -3/4. Could write that as a decimal, don't need to. So the equation of that line then, so y equals m, gradient, -3/4, plus c, which is 3 because the y-intercept is 3, or f dash of x-intercept in this case. So, of course, we don't actually want that. That's dy over dx, isn't it? Or f dash of x. So that is the gradient function. That is that straight line. So hopefully you can tell we're going to need to integrate that now. To go from the gradient function f dash of x to f of x is always integration. So let's integrate. So add 1 to the power, forgot the x there, and divide by the new power. Again, I will simplify all of this and work it out so it's not quite so messy in the next step. So if you're not sure, like, oh, what's -3/4 divided by 2, just do it on the calculator. So -3/4 divided by 2, it's -3/8. And there's our expression for f of x. So we've got a quadratic equation with an x squared, which we should have because we can see that f of x is a parabola, which is formed by a quadratic equation. Now this is where this point here becomes important. So the coordinates of this point are, so x is 0, f of x is 6. So a bit like we did in part A of this question, we can now that we've integrated, we've got this c that we need to find, we can substitute in the coordinates of a point that we know on f of x so that we can find c. So f of x is 6 and x is 0. Well, both of those terms over there are going to be 0, so it's going to be 0 plus 0 plus c, so 6 equals c, so c is 6. And that means that f of x is -3/8 x squared plus 3x plus 6. And that is the answer. We've found the expression for f of x. So again, this is a merit question, so you'd get achieved for doing the integration. So if you got to this stage, that would be achieved, and then merit for getting the answer. On to question D. Just move that a little bit further down out of the way. The function f of x equals ax cubed minus 4x has a tangent with a gradient of 20 when x equals -2. Find the value of a. So gradient of 20 when x equals -2. And we need to find the value of a. So a being this number here. So we've been told the gradient is 20 when x equals -2. So what we can tell from that is, so anything to do with gradients is going to require differentiation. So if we differentiate, let's see what we get. We're going to get 3ax squared minus 4. So that might not initially look helpful because we've still got an a in there. But it is helpful because we know the gradient is 20 when x is -2. So in other words, f dash of x equals 20 when x equals -2. So we now know f dash of x because we differentiated. And we know that that's going to give us an answer of 20 when x is -2. Now, putting that information into f dash of x, we can see how this is now helpful because a is now the only unknown. So we can solve this equation for a. So -2 squared is +4 times 3a will be 12a minus 4. Add 4 to both sides and divide by 12. And that gives us an answer that a equals 2, which is what we were asked to do, find the value of a. We have now done that. That one is an achieved question. On to the last question now. A right-angled triangle OAB is drawn within a parabola as shown below. 3 possible triangles OAB have been drawn. The point O is on the origin 0, 0, so that's here. And point A can lie anywhere on this parabola above the x-axis, so we can see those there. The equation of the parabola is of the form y equals mx minus x squared, where m is a positive constant. Use calculus to find an expression in terms of m for the maximum possible area of the triangle OAB. So in terms of m just means our answer is going to have an m in it. So the first thing we need to do is write an expression for the area, because we don't have one of those yet. We need an equation so we can work out what the area of the triangle would be. So the area of a triangle is half base times height. Half times base times height. So the base of this triangle will be the x coordinate. So I'm going to go half times x. And the height will be the y coordinate, which is going to be on that red parabola. So that's going to be given to us by mx minus x squared. So half base times height. So if we now simplify that, it will be a equals, so we've got half times x, so half mx squared, and then half x times negative x cubed, so minus half x cubed. So we've got an expression for our triangle now. Now, if we're trying to maximize that area, then maximization means turning point. So we're trying to make it as big as possible, so i.e. the gradient is 0. So that means we need to differentiate. So we go a dash equals mx minus 3 over 2 x squared. So again, maximization happens when the gradient is 0 and therefore the derivative is 0. So now we need to solve this equation. So again, it might look initially like we perhaps can't do that. But if we factorize it, we can take x to the outside, and then go m minus 3 over 2x. Like that. Which gives us two possible solutions. Either this x would have to be 0 to make the whole thing, or this x here, so we'd have to go m minus 3 over 2x would have to equal 0. So m would equal 3 over 2x, so x would equal 2 over 3m. Okay, we're nearly there. So to maximize the area maximizing area will happen when x equals 2 over 3m. So if we substitute that back into this equation here, this m value, then we should be able to work this out. Again, it's going to be in terms of m, so we're not going to get a definitive answer. It will just be, there'll be an m, and it's a equals something m. So area is 1/2 so area equals 1/2 times the base. So base is x, so that's 2 over 3m, times the height, which is mx, so again x is 2 over 3m, minus x squared, so 2 over 3m squared. So, got quite a bit going on there, so let's try and simplify it down. So half of 2/3 is 1/3, so that'll be 1/3 m. I'll just put all that in brackets. M times 2/3 m will be 2/3 m squared. And then minus 4 over 9 m squared. So to square brackets, square the top, square the bottom. If in doubt, you could do just 2/3 times 2/3, so that's 2/3 squared. And then notice both of those are m squareds in that bracket, so I'm not going to expand just yet. I am going to do that. So again, do this on the calculator. So 2/3 take away 4/9 is 2/9. So that is 2/9 m squared. And then do 2/9 times 1/3 is 2 over 27. And then m times m squared is m cubed. And that is an expression for A in terms of m. The maximum possible area will be 2 over 27 times by m cubed. Okay, so here's the marking. For achieved, correct differentiation of an expression for the area. So all the way back over here. So we have to get to this stage here. So forming the expression for area and then differentiating it. For merit, finding m or x. So if you got to here, and then all the way down here, you'll be pleased to know is an excellence. And that concludes our walkthrough of exam questions based on the 2020 Level 2 Calculus exam.